can use that infrastructure as well. Next slide. So this is our exploration roadmap, and I like to think of it as a destination roadmap, really, because right now our destination is low Earth orbit, the International Space Station, which we have occupied now continuously for more than 6 years. And the shuttle is helping to service that along with international spacecraft. And we hope that our COTS program that Shannon mentioned will begin to take up that servicing too very soon. We also are conducting research and technology demonstrations on board the International Space Station. A lot of that work being done out of Glenn Research Center. Again, utilizing that outpost as a stepping stone to move off of the planet and beyond. Now we're turning our attention to our Earth's nearest neighbor, the Moon. What I'd like to do is show the next slide, please. And this just gives you an idea. As you look at low Earth orbit, you know, we're only about 240 miles any time in our circular orbit on the International Space Station. So, you know, distance from here, say, to Cleveland. So we're fairly close, even though we're going at 17,500 miles an hour. So we're going by fast. But when you start to look at going out to the Moon, it's actually 1,000 times farther, 240,000 miles away. Interestingly, it takes two days to get to the International Space Station. It only takes 3 to get to the Moon, but you need a bigger rocket. So, but anyway, so a much greater distance, and so that increases the difficulty in logistics and some just getting the infrastructure there. And so we have to be very smart in how we do that. We have to develop new capabilities for rocket propulsion, and also figure out how we can live off the land to reduce the logistics we need from Earth to the very minimum. And then Mars is even much farther out, and as Shannon mentioned, about a 6-month trip out. So there we really need to hone our skills of living off the land and our propulsion and life support capabilities before we venture out for such an ambitious mission. Next slide. And so with this exploration roadmap, we are starting to develop some of these systems that will enable that future exploration. The Ares 1, of course, and the Orion Crew Exploration Vehicle will be that initial capability that we hope to field in the 2014-2015 timeframe, but also to develop the Altair and the Ares 5 rocket that will really enable that lunar capability. And along with that, then the surface systems to provide the outpost and the capabilities to exploit the lunar resources. Next slide. And to enable these destinations, we are developing through our lunar precursor missions good maps, topographic maps that will help us to pinpoint landing sites and to help us to understand the environment from resources to the radiation fields. Also develop the technologies to develop capabilities from robotics to propulsion. And then also perform human research that will allow us to make sure that our astronauts, when they go farther, can venture more safely and productively. All those things and the COTS will give us the exploration capabilities that we need then to accomplish this new mission. Next slide. There's a number of exploration themes, again going back to the why we're doing this, and you know, certainly we've identified these themes with the global community. Some of them we're very much involved with right now. Some of them, like the first one, human civilization moving off the planet. Well, we don't see any mass migrations happening really soon, but the ability to get to other worlds, I think, is one of the more important evolutionary opportunities that we have to make sure that we can become a multi-planet species. But things like exploration preparation, the Moon allowing us to demonstrate what we need to go beyond, economic advantages through the development of in-situ resources, scientific knowledge. The Moon will enable tremendous knowledge gains about the sun, about the formation of our home planet, and about the environment of the solar system. Global partnerships. We're engaged now with 14 nations trying to plan our path to the moon. So we plan to go with other nations, leveraging the knowledge that we've gained with the International Space Station community. And also, again, public engagement, trying to inspire that third generation of space explorers, as I was the second, inspired by our first astronauts. Next slide. So again, the moon, why the moon? Well, because it's close. You know, it's 3 days away as opposed to 6 months. It's alien yet familiar. From the moon, the Earth is visible. From the Earth, the moon is visible. If you saw the eclipse yesterday, you know, it's just there, and say, why don't we have people there? And we can use existing capabilities. Our rockets that we have right now, with modifications, can get us there to the moon. Our transportation systems that we develop for the moon will also enable future destinations as well, such as Mars. And again, it will retire the risks that we will face for future exploration missions. Knowing how to land, how to gather in situ resources on the moon will allow us then to better exploit Mars when we go there as well. And we have the ability then to understand what sort of logistics train we need for exploration, and then also to advance science. So a lot of good reasons why the moon should come next. Next slide. One of the areas that we've identified is Shackleton Crater in the South Pole. Now we're going to try to hone in on this using maps from the Lunar Reconnaissance Orbiter that we hope to launch sometime in the fall of this year. But Shackleton's interesting because it has sunlight almost continuously, so an outpost can utilize existing technology using solar panels to provide the electricity for the outpost and for in situ resource utilization initially, and then looking then down the line at other energy sources as our infrastructure increases. Next slide. And again, as we look at elements of an outpost, developing the lander and the ascent vehicle, developing good extravehicular activity systems, spacesuits, tools that enable explorers to explore freely. Power, I mentioned, very important. You can't do much without electricity. A closed-loop habitation system to reduce the logistics needs. Mobility on the surface to explore beyond. Nav and communication capabilities to get that data back home to Earth. And then, as I mentioned, in situ resource utilization.